Next, we shall move on to special ICs. In this first, we are going to study about 555 timer circuit, functional block and its characteristics. The 555 timer is a highly stable device for generating accurate time delay or oscillation. Some of the applications of 555 timer circuit are oscillator, pulse generator, ramp and square wave generator, mono-shot multivibrator, burglar alarm, traffic light control and voltage monitor, etc. So this is the pin configuration of 555 timer IC, and this is the functional diagram of 555 timer. Here you have a control flip-flop, two transistors Q1 and Q2 and two comparators. One is upper comparator, other one is lower comparator, and an inverter as a power amplifier. Three 5 kilo ohm internal resistors act as voltage divider, providing bias voltage of 2/3 VCC to the upper comparator and 1/3 VCC to the lower comparator. These two voltages fix comparator threshold voltage. Also aid in determining the timing interval. The transistor Q2 serves as a buffer to isolate the reset input from flip-flop and transistor Q1. The transistor Q2 is driven by an internal reference voltage V reference from supply voltage VCC. A negative going trigger pulse is applied to pin 2 should have its DC level greater than VCC by 3. Output of the lower comparator goes high and sets the flip-flop Q equal to 1, Q bar equal to 0. During the positive excursion, when the threshold voltage is at pin 6 is 2/3 VCC, output of the upper comparator goes high and resets the flip-flop. That is Q equal to 0, Q dash equal to 1. Next, monostable and astable modes of operation of this 555 timer IC circuit. A 555 timer connected for monostable operation and its functional diagram. So this is the connection for monostable operation. Next we have the functional diagram for monostable operation. So this is the functional diagram. In the standby state, flip-flop holds transistor Q1 on, thus clamping capacitor C to ground. Output remains at low. Trigger through VCC by 3, the flip-flop is set, that is Q bar equal to 0. This makes Q1 off. Short circuit across C is released. As Q bar is low, output goes high, almost equal to VCC. Voltage across capacitor C rises exponentially through R towards VCC. After T, capacitor voltage is just greater than 2/3 VCC. Upper comparator resets the flip-flop, thus makes Q bar equal to 1. Q1 goes on. The capacitor C discharge rapidly to ground. Output returns to the standby state. The voltage across the capacitor is given by Vc equal to VCC into 1 minus e power minus t by Rc. at time t equal to capital T, that period, Vc equal to 2 by 3 Vcc. So equating these two things, therefore 2 by 3 Vcc equal to Vcc into 1 minus e power minus capital T. You replace small t by capital T, e power minus capital T divided by RC. So when you simplify this equation, you get a t equal to RC natural logarithm of 1 by 3, or time period t equal to 1.1 RC. If a negative going reset pulse is applied to the reset terminal, transistor Q2 goes off, Q1 becomes on, C is immediately discharged. So the various waveforms associated with monostable operation is shown here, and finally the output after reset pulse applied is also shown separately. Next we have a stable operation. So this is the connection for a stable operation. Here we have RA, RB and capacitor C. So this is going to be the functional diagram of a stable multivibrator using 555 timer. So functional diagram, what is inside the operation. When the power supply VCC is connected, capacitor C charges towards VCC. During this time, Q bar equal to 0, and the capacitor voltage is just greater than 2 by 3 VCC. Upper comparator triggers flip-flop so that Q bar equal to 1. This in turn makes transistor Q1 on. C starts discharging towards ground. Current flows into Q1. See, as it reaches VCC by 3, the lower comparator is triggered and turns Q bar equal to 0. Capacitor C is thus periodically charged and discharged between 2 by 3 VCC and 1 by 3 VCC. And these are all the waveforms associated with the stable mode of operation. So output is going to be a square wave output with the on time and off time, that is T high and T low. So during T high, the capacitor charges up to 2 by 3 VCC from 1 by 3 VCC, and during T low, the discharge of capacitor takes place. So the capacitor voltage and the output voltage. So T on plus T off, or T high plus T low, gives you the total period